Hi everyone, today we'll be going through this GCSE vectors question. So let's give it a read. Two vectors are defined as follows. Vector A to C is defined as -2, -1. Vector A to B is defined as -1, -4. And we have to find the value of cos ACB in its simplest form. Okay, so the first thing that's important to understand is, what does a column vector even mean? So if I have x and I have this as y, right? Now notice that x can be one of two things. X can either be positive or it can be negative. If x is positive, that's a movement to the right. If x is negative, that's a movement to the left. Similarly, y can either be positive or negative. If y is positive, that's a movement up. If y is negative, that's a movement down. So let me give this a try now. So the common point that they both share is A. Because A is a common point, the easiest point to view A as would be the origin. So I'm just going to draw this out. So if I draw this out, let's see what I have. So if I view the origin as A, so I'm going to label that A, then to get to C, I must move 2 to the left and 1 down. So 2 to the left and 1 down would take me here. This would be C, and that's the vector A to C. And now, I need to find the vector A to B. So first I need to understand, to go from A to B, I have to move 1 to the left and 4 down. That's what the column vector -1, -4 means. So I'm going to move 1 to the left and 4 down. That takes me all the way over here. So that would be the point B. Now that I have A, C and B clearly plotted, what I need to do is I need to connect C and B to complete my triangle. So I'm going to do that. Now it's important to understand that when they say find the value of cos ACB, they're essentially saying the angle between the lines AC and CB. Okay? So in this case, it would be this angle theta. Now, if I want to find this angle theta, it seems quite difficult to do at first glance, but I should notice something. That to go from A to C, that's just a movement of 2 and 1. And this is a right angle triangle. Yeah? Critically, this is a right angle triangle. So why is this of use? The reason this is of use is because I can now work out the length of AC because it's the hypotenuse of my right angle triangle. Also, I should realize that I could do the same thing with the length of C to B and the length of A to C. So C to B would also be a right angle triangle where the length would be 3 and the base would be 1. And again, A to B would also be a right angle triangle where the base would be 1 and the length would be, the height would be 4. So now that I have that, I should work out A to C, C to B, and A to B, right? So if I start with A to B, the actual magnitude of A to B, right? Well, the magnitude of A to B would just be the square root of 1 squared plus 4 squared. So that would just be the square root of 17. That's easy enough. If I work out the magnitude of A to C, so the magnitude of A to C, that should just be the square root of 1 squared plus 2 squared. So then the magnitude of A to C is just the square root of 5. Now if I'm working out the magnitude of C to B, that would just equal the square root of 1 squared plus 3 squared, which just gives me the magnitude of C to B as the square root of 10. So I have each of my lengths of my triangle. So let me extract the triangle and fill in this information. So my triangle, just vaguely speaking, looks something like this. This is A, C, B. A to B is the square root of 17. A to C is the square root of 5. And C to B is the square root of 10. And this is the angle theta. Now I know I can apply the cosine rule. So let me just write that out over here. I know that cos A equals B squared plus C squared minus A squared all over 2BC. For anyone who wonders how I got that, if you see the cosine rule is actually just A squared equals B squared plus C squared minus 2BC cos A, and I've simply rearranged this. So I've taken minus 2BC cos A to the other side and A squared to the other side to get 2BC cos A equals B squared plus C squared minus A squared, and then I divide both sides by 2BC, leaving me with this formula over here. So now I'm trying to work out cos A, right? In this case, A would be ACB, which is what I'm after. So cos ACB equals the square root of 5 squared, add the square root of 10 squared, minus the square root of 17 squared, all over 2 multiplied by the square root of 5 times the square root of 10. So then I get cos ACB as, so that becomes 5 plus 10 minus 17, so 15 take away 17, which is just negative 2. So I get negative 2 over 2 root 50. The 2's cancel. So then I get cos ACB as minus 1 over root 50. Then I can just rationalize this to receive cos ACB as minus root 50 over 50. And then I can break root 50 down into minus root 25 times root 5. No, sorry, minus root 25 times root 2. So then I get minus 5 root 2 all over 50. And that simplifies to minus root 2 over 10. Just like that. So again, that equals cos ACB. And this is cos ACB as required.